right, so how are we doing for time? A little under, so I will try to whip through this one, hopefully. Okay, and then we can get on to aphids. So we're gonna obviously touch more on pesticides as we talk about different pests, but I just this is the last of our sort of like general overview kind of slideshow. Just talking about pesticides and where they fit in as like a general concept in integrated pest management up here in Canada anyway. So I briefly touched on these pesticide issues before, and they sort of fall into different categories. So the green ones are sort of philosophical, or, you know, things like worker safety and environmental concerns. Then there's sort of the access issues. So in Canada, we have limited registrations. We also are going through a wave of deregistrations as our products get reevaluated every 5 years for efficacy as well as health and safety information. And also we can have changes in use patterns. So a product may not get totally deregistered, but our pest management regulatory agency may decide it's no longer safe to be used on cut flowers, or the reentry time needs to be expanded, or things like that. Also, just in terms of access, market can be an issue here in Canada, and just with floriculture in general, it's obviously a smaller market than, say, corn. And sometimes the pesticide registrants just don't want to spend the money to generate the data to get the product accepted for use in ornamentals or in Canada. And then there's sort of production issues with pesticides. So things like coverage, like how do we get the product on in the right place properly, as well as resistance, which is probably one of the big ones. So I think it's important to point out that these issues don't exist in a vacuum individually. They often are interacting with each other to make the grower's life harder. So for example, Bemisia whitefly is obviously a problem in poinsettia. So this is an example of, these are the products recommended by Michigan State Extension. And in Canada, this is how our access to pesticides lines up. So you can see that we can't even really do their program because half the products are either not registered, they're becoming deregistered. We already have resistance, probably because they've been registered in the States for a much longer period than when they were available here. Or we're probably just never going to get them for whatever reason. We tend not to get mixes of products for some reason. Anyway, so obviously this is where resistance and availability meet to make things really, really difficult for growers here to think of pesticides reliably. And that's really why we've shifted a lot to what we call a biocontrol-based IPM system. So we still practice IPM, but the backbone of that is usually biocontrol, simply because of these issues. Again, coming back to issues not existing in a vacuum, we know from work that was done by Coper that analyzed samples from a bunch of different plants. Mike, I believe these were poinsettias. But anyway, they looked at a whole bunch of samples of cuttings that were coming in to Canada from offshore the US. And these were all the different pesticides that were found on these plant samples. And so the ones highlighted in green are the only ones that are really considered somewhat compatible to biocontrol agents. And the rest have a very real possibility, especially at the levels they were found at. Even though it was parts per million, it's enough to have sublethal effects on a lot of natural enemies, especially really sensitive natural enemies, things that we call the canaries in the coal mine, like Delphastus and diglyphus that's used for leaf miner to parasitize that. So you have all of these products that are creating resistance in the pests that are coming in, and all of these products that are, the residuals can make your bios less effective. So again, it's that sort of interaction that's really what's affecting growers. So all of this is to say that all of these issues can join together and give you basically the perfect storm, and it can be a struggle. Something like, you know, having a pesticide-resistant pest and a consumer that has a low tolerance for insects, but also doesn't want to accept any products treated with neonics can leave you in a place that's very difficult. So that's why up here we tend to focus more on biocontrol. So we do use pesticides, but often, sometimes not successfully. So Mike and I have sort of come up with a list of the top 5 reasons why pesticides fail. And even though we're talking about this from a Canadian context, I do think these reasons are translatable to other areas as well. So the first is resistance, which we've talked about a little bit. I'll talk about a little bit more. Inadequate rates, so sometimes just errors in calculations, and we'll show an example of just how labels are not made for the greenhouse industry. The rates were really made for outdoor application of crops, and then ornamentals are usually just stuck on the label. So it can be really hard to translate what amount you're supposed to be spraying to get the proper AI onto the plant. There's also issues with killing accidentally or using expired products, and I'm talking here specifically about microbials. It's a big issue there that we've run into a lot in the last 5 years as microbials become more popular. Inadequate coverage is always a challenge, just because a lot of these pests like whitefly and thrips and aphids all want to be on the underside of leaves, which can be hard to get to if it's a contact pesticide or even translaminar. And then the last reason why pesticides fail, I consider a grower going from more of a biocontrol based program to ending up on a pesticide treadmill as a failure. So things that trigger that action or result. So first, just talking about resistance issues, where do they come from? Well, often the source is offshore cutting. So this is an infographic for chrysanthemums that I'm going to be talking about later in the thrips section. But basically, we get our cuttings in from these offshore sources or the US, and data from Rose Boutenhouse at Vineland Research and Innovation Center. She actually counted the numbers of buggies that came in on cuttings. So this is the number of pests per 100 cuttings. And you can see that the thrips levels were as high as 70 or 80 thrips per 100 cuttings, depending on the supplier. And same with spider mites. And they didn't just come out on the first that showed up 7 days later as they hatched. So we know these pests are exposed to all those pesticides that I showed you before, and they're coming in on our cuttings already resistant. So that's my resistant thrips. It's fluorescent pink. So how do we manage resistance? So part of it is being aware of chemical classes and of course rotating. Obviously that can be hard to do if you aren't the one who put a lot of the products on that the thrips or whitefly were first exposed to. So if you have good communication with your suppliers and they can let you know of what chemicals they've already applied, then you can pick ones from different categories if they'll share that information with you. That's not always possible, but it's worth a shot. Also consider integrating chemicals by crop stage. So an example would be using biocontrol on your stalk and in propagation, and saving your pesticides for the finished crop. Or the flip side of that is to apply pesticides early that are one and dones, and I'll show you an example of that, and then never having to put pesticides on again. So really, instead of thinking of it as a weekly or a constant battle, think of strategizing by when will this pesticide have the most impact on the pest and the least impact on the rest of my biocontrol agent. So for example, Mike and I have noticed for years that growers who save their pesticide applications for the finished crop, notice they've got a much more susceptible population of pests if they use biocontrol the rest of the way before. So partially because having resistance to chemicals, there's a genetic cost to the insects, like a fitness cost. So having those genes can often make them less fit in other ways. So maybe they're not as good as mating, or their development time is slower. So you end up, when you use biocontrol, you end up shifting the population a bit more to these more susceptible ones, because being susceptible tends to have less fitness or energy costs to the pest. So I'm going to be talking more about an example of this delaying of pesticide applications by using biocontrol earlier in the crop when I talk about whitefly. But it's basically exactly like I said, you use biocontrol at the beginning, and it prevents, we've shown that this prevents the Q biotype of Bemisia, or Q species, sorry, I should rather say, from taking over. So using the biocontrol first is like buying insurance for your pesticides later. So if you do need to use them at the end to clean up, there's a way higher chance they're going to be successful. And here's another example of managing resistance just with good planning. So these are notes from an actual grower, oops, whose name is visible. Sorry about that. I'm sure he wouldn't mind if this was shared. Those black bars are supposed to be over. Anywho, so what he does very smartly is he plans out all the plants he's going to grow for the spring, and then maps out his main pests, and then has a plan of what he's going to do for each of those. And then he knows if they're going to interact with each other. So for example, in terms of the one and done situation, New Guinea impatiens, just as an example, we know they can get spider mites or broad mites. So he does an early application of a miticide, and that's just like a one and done. So you're applying it on a small area, so just one plant or one kind of plant. When they're very small, you're putting on this pesticide, but that technically is kind of a toxic chemical, you know, something like Avid or Pylon. But those New Guinea impatiens, they don't get any other pests. They don't tend to get whitefly or thrips or anything like that. So those chemicals won't be interfering with the biocontrol program for those later. And because you've only applied it to a small area, you're also not interfering with your biocontrol programs for other crops that might get different pests. So that's an example of doing a pesticide early and then just leaving it alone after that. So one of the other things we earmarked as reasons pesticides can fail, especially in Canada, where we get these minor use label registrations for products, which is basically a fancy way of saying we get tacked on to an existing registration, is errors in calculations, because our rates on labels sometimes look something like this: 750 to 1,000 milliliters per hectare. So what does that mean in terms of how much am I applying per a chrysanthemum plant or a poinsettia? If I'm drenching this, how much AI am I drenching in 150 milliliters of water? So you really have to do the calculations yourself by how much water you need per your compartment area, so say for 10,000 meters squared. And then for drench volumes, there are standard amounts you can find per pot online. So for example, 150 tends to be the standard for a 6-inch pot. And you can obviously turn to your company reps too from the pesticide companies. They may have a better sense of what that means per pot if they're experienced in the field or in the greenhouse rather than just guessing. So anyway, something to be aware of. So our third reason we noted for pesticides failing can be mishandling of microbials. So microbials are great, but they sort of fall into that gray area of, are they biocontrol or are they pesticides? And they sort of have characteristics of both. So, you know, they have low REIs, they have no maximum application limit usually. They have minimal non-target effects. These are all great things, but growers also like them because you can apply them like a chemical, and you can also store them like a chemical, which is handy. But growers sometimes forget that they're actually alive, so they may not pay close enough attention to the label and how they should be stored. The microbial microbial insecticides can actually differ a lot, and can the fungicides as well. Not all of them just go in a room temperature pesticide locker. Not all of them go in the fridge. Each of them are sort of happy in a different environment, so you have to make sure to read that label. And also, if you're putting them in something like a pesticide cabinet, I've seen growers totally nuke their bottles of Botanigard because that pesticide cabinet is like in a metal cabinet in a concrete room with no ventilation. And the temperature in there is going up past 30, which is just like for a sustained period is going to kill those resting fungal spores in there. They also may or may not be applied optimally, again, because of sort of that false sense of they act like a pesticide. So it's just something to be aware of. So like with your biocontrol agents, I showed this slide before about reading the instructions. You want to read the instructions on the bottles of your nematodes or microbial fungicides or microbial insecticides. Figure out how to store them, how long they're good for, how best to release them, and obviously talk to the company reps who are super, super knowledgeable in these areas. And then along with microbials as well as traditional chemical products, you might need to rethink your application for the product to get adequate coverage, because we also see that as leading to failure. So a good example that I've seen a lot and worked with some academics and also bioworks on is the proper application of something like Botanigard. So you'll notice on the label it says spray to glisten, which is a bit of a, I don't want to say confusing, but it's hard to know what that means. Traditional pesticides obviously say spray to runoff, and that's pretty obvious. You put as much product on until you see it build up on the leaf and then run off. But spray to glisten is sort of a foreign concept, and what does that mean? Essentially, it means we want a really light dusting of this product to land on the leaf and make as many conidia as possible just lightly on the leaf surface so the thrips, for example, can run into them. And we also want to create this sort of cloud effect so that the product goes under the leaves as well and into the plant canopy, and some of the conidia stick there as well too. So I'm going to show you an example from a grower who uses a traditional sprayer to get this nice cloud effect with his Botanigard, but he applies it very differently than a lot of other growers in the region.
Because he's doing this.
You can see him
it is over there.
poofing it sort of in the air
Nope.
with the wand held really high up.
I just wanted him to spray
And
that
he's
he
walking backwards pretty
does the
quickly.
normal
He's
move.
walking backwards as fast as he can. And you can see that it's just like a really light dusting or cloud effect. And we actually compared this application strategy to using an LVM to apply Botanigard. And we actually got the same coverage of conidia on both the top and bottom leaves using a hydraulic sprayer in this fashion versus an LVM. But LVMs obviously have the benefit of sort of like turning it on and walking away for several hours. And so they can be really good for a lot of products. So if you haven't really thought about changing up your pesticide application or buying new equipment, it may be time to sort of look back into buying an LVM machine potentially. And also there's information out there on which sprayers, some sprayers can actually kill microbials. So thermofoggers, the temperature ends up being too high and it can kill Botanigard spores. So being aware of that information as well. All right. Also regarding inadequate spray coverage, it can be good to arm yourself with more information about sprayers and nozzles. So one of my colleagues at OMAFRA has created a great website called Sprayers 101. It's obviously geared more towards field application, but there is a lot of good information in there that I think has just gotten bypassed by the greenhouse industry. So I encourage you all to take a look, and I think it's just sprayers101.com, but I can add the link to the chat after. And also there's some hilarious videos that seriously need to be watched. I don't know how he's gotten permission to do all these fun things, but they're having a good time over there at Sprayers 101, that's for sure. So the last thing we want to talk about in terms of why pesticides fail is avoiding the pesticide treadmill. And that really comes down to understanding compatibility. So what does that mean? And can it be achieved for all the pests in your program? So a lot of the different biocontrol companies like Copert and BioBest have these really great online databases that everyone should be checking out. Basically that have amalgamated all the information out there on direct toxicity of different pesticides to the biocontrol agents that are available. So for example, we've got something like dichlorvos, DDVP, different application types like spray versus drench, and different bios and even different life stages. And you can see they're usually categorized by number or color. So like a higher number and more towards red is bad. They also indicate persistence often. So generally, the lower numbers 1 and 2, they mean non-toxic or slightly toxic. But note here that slightly toxic here means 25 to 50% reduction. And then obviously 3 and 4s are the bad guys. You don't want to get up to that because that's up to losing 1/3 of your bios through direct death. So like they eat the pesticide or the pesticide gets on them and your bios die. As much as I think these are a great starting point, I think they can give you a false sense of security if this is where you stop. And that's because these lists, yet anyway, don't really include sublethal effects. So things that may not kill the insect, but really, really reduce their performance. So for example, reducing their oviposition or even reducing their ability to search for pests or their flight capacity, all of those things that go together to make your bio the best bio it can be. And then I also really think we need to reconsider this paradigm of slightly toxic. Like, so I really don't agree with 50% losses, meaning slightly toxic. You're really losing 50% of your bios every week if you're applying a pesticide with them. So I just want to give this as food for thought. This was developed by my predecessor, Graham Murphy, here at OMAFRA. And this is how he looked at it. And I agree with this, is there are no truly compatible pesticides out there, because that would mean they would be compatible with all bios, and we just don't have those products. So we have ones that are somewhat compatible. So they have low mortality to most bios and minimal sublethal effects that we know about at least. But even these can affect some of our bios. So Botanigard, for example, we know is not compatible with Aureus. It will kill it. Exarel or Ference is a new registration here in Canada. It's safe on predatory mites, but we know it is hard on Delphastus and has unknown effects on parasitoids. So we also have chemicals that are toxic. So we know they have, they kill things directly, but they have a place in IPM mostly because they have short residuals. So that's things like landscape oils, soaps, and DDVP that are really non-discriminatory. They'll kill anything, but they're really not toxic when they're dry. We also have chemicals that are highly toxic that are sometimes needed. And these are sort of your emergency cleanups or spot sprays. So things like Pylon, Contos, and Success. These have high mortality, but also high persistence in the environment. So it's important to note that. And things like Success and Contos can be hard on predatory mites with up to 2 weeks of persistence. So you want to be careful when you're using them, and using them either at the very beginning of the crop or the very end of the crop, like we mentioned before, might be a better way to use these products. And then we have things that I categorize as super duper toxic that basically we never want to see used in the industry, because it would just mean getting back into a biocontrol based IPM program would be far too difficult because they have really, really, really long residuals. So lastly, with the compatibility considerations, just think about what will the sprays do to other bios in your program and how long will they affect them. So think about secondary pest outbreaks like leaf miner, again, diglyphus being that canary in the coal mine. Also think about what happens if you spray it, and if crop losses will be worse if you spray it and that chemical fails to do resistance. Will you wipe out other programs and still have your original problem? And also consider context. So environmental stress makes pesticide side effects worse. And then also think about crop timing. Can you avoid doing a pesticide cleanup just by leaving a compartment empty if you shift plants around and heating that up and letting the pests die in there with heat but no food. So those are just some things to think about. And I think I have one more slide. Here we go. Move my head out of the way. So tools to help in terms of knowing the compatibility of different pesticides with biocontrol agents. This isn't something that's readily available in a lot of pesticide tables. So I actually made a big pesticide table, obviously for Canadian products. But basically it lists all the registered products we have by pest. It gives you all the information you would normally have on the label, like application numbers and blah, blah, blah. But it also gives you compatibility data. So it'll say something like hard on predatory mites, and then you can zoom over the cell and it'll give you some more details. And also phytotoxicity information as well. So when it also has hyperlinks, which I cut off here, but basically hyperlinks to each of the most recent labels, which is important in Canada when we do a lot of changing of use patterns or what crops they can be applied on and things like that. So the hyperlink will take you to the most recent label on the Health Canada site. Just make sure to click the registration number. It makes more intuitive sense to click on the name, but the name just takes you to the history of the product, not the actual label. So click on the registration number. And that is available on my Floriculture blog as a downloadable table that you can change or add notes to. And I'm putting up a more recent version in a few weeks. So just to sum up, pesticide use obviously is possible, but with good planning, knowing when you want to use them regularly versus emergency use, and sort of knowing in advance what product you're going to grab first and what the ramifications of that product are. Thinking about your resistance management and optimal application, and understanding true compatibility and looking that up before you apply any products.
Actually, while we're waiting, I got the first question in, and it's
yeah, if we can answer questions now, that would be good too.
Yeah, thanks, Greg. It's, have you ever experienced resistance development with bios? And I think you mean, are the bios becoming resistant to pesticides? The only thing I can comment on that is quite a few years ago, decades ago, John Elliott at Applied Bionomics worked on a system where he actually sprayed increasing amounts of pesticide on predatory mites for that exact reason. In those days, of course, we were using very toxic things, so he was using quite toxic chemicals. Unfortunately, it wasn't very fiscally advantageous to his company, but it did work. So there is a school of thought is if you expose them in incremental amounts of pesticide, you probably can get some sort of resistance to it. There are certain, I'm not sure I would probably concentrate on predatory mites, because there is some that are a little bit hardier than others, as opposed to some of the flying insects and that sort of parasitoids. So, so it's a very good question. Sorry. Oh, sorry. Okay, sorry. I meant, have you ever seen the pests becoming resistant to a biocontrol? I haven't, although there is some, I think there is some work being done on that, and maybe Sarah, you can chime in. I know some work down in London on spider mite control, and I've had that conversation with them, and they have told me that they thought that biocontrol could be resistant to the new resistant strains of spider mite. I haven't seen it myself, and that's one thing I look at very closely, is whether the biocontrol is doing what they're supposed to be doing. I will get into, actually in this talk, of some failure of some of the biocontrols. So, and it's not due to resistance; it's due to other things. I hope that
Yeah,
answers your question, Greg, but sorry, I don't have any more than that.
Yeah, I would
okay,
generally say, Mike, I'll just pop in there for a second.
Sure.
Yeah, I agree that I haven't really seen it either. I mean, these insects, say parasitoids and, you know, aphids have been in this dance of evolution for, you know, millions of years. And in our lifetime, it's unlikely they're going to be able to develop true resistance to them. They can, you know, they do have some defenses like encapsulation of things like parasitoid eggs or fungal spores, but usually because we're releasing such high numbers of different bios, it overcomes that. So I haven't even seen resistance develop to things like microbial insecticides, which you would think would sort of be the first place you would see it. So, and it would be very hard to develop resistance to a generalist predator that just eats your whole self. So in general, I think that's a concern that can sort of be like put to bed. I think mostly when people see that bios suddenly aren't working, it's either a quality control issue or it can have to do with how the bios are being reared at the commercial end, and maybe they're just not optimized. So I'm sure Mike will touch more on that.
Yeah, well, I will just add that you know, insects will adapt. So so they are adapting to different things. So suppose you know, the strips fighting off predatory mites, for instance. Did that always happen? You know, we have no way of knowing, but in our greenhouse system, sometimes that happens when the larva, and Sarah has some great video of that. So it is possible that they adapt to certain conditions where they're being attacked and fight things off. But I wouldn't call it resistance. I mean, they're still, you know, ultimately being controlled, but they put up a fight.